ahead and record on this computer. So today we're going to be working on with loops and strings in the accumulator pattern. So first and foremost, I want to talk about the brilliance and amazing thing that is, first let me delete these things. I want to talk about the brilliant and amazing thing that.
This was true.
You want to watch something else on the TV?
That's true.
All right, take attendance. I'm going to set that up for him on the TV. Give me 1 second. I'm putting on this one because I need to work with my students. Whew. Okay. So, okay, sorry about that. Let's go ahead and share my screen, and I want to show you something that I really like about from Temple, which is this little thing from account management over here. So I went to go and change my password just to show you as an example. Right, so agree to policies, change password, right? You cannot reuse your last 3 passwords, but what it does over here is that the longer your password is, the less requirements it has. This is actually really good because the longer the password is, the harder it generally is to remember, but it depends on what we're talking about when it comes to length, right? If it's 4 words, that's not hard to remember. Right, whereas 20 characters, that's hard to remember, but 4 words, not so much. So, for example, they say use correct horse battery staple, which is actually a reference to the comic at the top of our project page today, which is from XKCD. So let's take a look. Right, the idea here is that you've got Troubadour, right, as your password, and then you make some common substitutions, and then maybe you add a punctuation and numeral at the end. God knows I do. But and this measures basically the uncertainty of it in something called entropy. Basically says the computer if they're trying to crack your password specifically, it's going to take about 3 days for it if it's weak. But it's not, but it points out that this is not really the way password breaking is going to work. We're going to discuss that today. But the point being is that it's easy for the computer to figure out passwords that are based off of a word, even with common substitutions. And for you, that's hard to remember. Whereas taking 4 random words results in a super long password that's super hard for the computer to get. But correct horse battery staple is super easy for you to remember because you've already remembered it. So through 20 years of effort, we have successfully trained everyone to use passwords that are hard for humans to remember but easy for computers to guess. So what we're going to do today is demonstrate how to basically make our make passwords. We're going to write a password generator. So this problem is broken up into multiple parts. And I'll work with you to do the first one, and then I'm going to let you do the second, or all the remaining parts. So in the first part, we're going to create a traditional random password just by combining an 8-letter password made of random letters and numbers. And now what we're going to do, and then the next part, we're going to instead look at creating a password out of 4 random words and stringing them together. And then we'll look at maybe taking that and having to deal with other things. And then finally, the last part, which is a bit of a challenge, is kind of looking at how quickly can computers actually guess a password. Right, so we'll be writing a basic, we'll be using this code and writing some basic stuff over here. Even though we haven't really hit if statements or while loops, it'll be interesting. We'll be able to walk through this and explain this. It's not too hard, and that's definitely a preview of things to come. So this is our reach. And then we can do some calculations as to how long it takes to crack passwords. Okay. Passwords, by the way, are typically stored. And here's the way passwords typically work. Typically, you're on a good designed system or website. The website does not know what your password is, actually, in truth. It could not tell you what your password is if you request for you. I'm sure you've all worked with websites where you've sent a email, like to say, hey, I forgot my password, or you click the button to say, hey, I forgot my password, right? And then it, and then it sends you your password in the email. Okay, and let's see. This is chapter 5. This is chapter 6-ish. But I mean, this is all about for loops and working with sequences, but we're not going to be doing anything too complicated. We're going to be drawing on bits from chapter 4, chapter 5, and chapter 6. Thank you. The annoying I'm not a robot. That's useful. But the point being here is that that instead, the way passwords are stored on websites is used typically through a salted hash, which sounds like it's something tasty, but really it's just simply a algorithm where basically it converts your password. It's a one-way conversion of your password into a random string of characters. And then basically the way it checks it is that you enter your password, it runs the same algorithm, and then it checks, hey, does the output equal the output we have stored? That way, if we get a website breach, your password isn't really in jeopardy. So there's more to it than that, but that's generally the idea. So first, let's go ahead and create a traditional random password composed of numbers, letters, and a few random special characters. So for this, I'm going to make use of one of the more awesome features in the random library, random Python. I'm pulling it up. So the random module, random Python docs. Went to the wrong place. Here we go. Random, generate pseudo-random numbers. There's a bunch, so rand range is typically rand int is the big one that we use a lot. But the other big one we'll use during the semester is random.choice, which basically says, given a sequence, choose something at random for it. Now, again, we can get into a heavy philosophical debate about, is anything truly random or is everything deterministic? But this is pseudo-random, meaning that if we plot our choices on a statistically, it'll be approximately uniform. So what we're going to do is that we are going to take a look at how this looks. So import random. Now, you can put the imports anywhere, but I like to put them at the top. So random.choice, let's just take a look at how that looks. Random.choice letters plus random.choice letters. So I'm going to go ahead and print that out. So we're save and run. ZZ, JE, VO, VL, GA. So this is actually fairly random. So, so basically it's making a random choice for the first letter, random choice from the second letter. If I change it to caps, it will be this. And if I instead change it to numbers, it will be doing a letter and a number. So we want to use all three of these to generate a password. So what we're going to do is we're going to create something, I'm going to call it options. And that's going to be letters. Options is equal to letters plus numbers, plus caps plus numbers. Concatenate all our options together. So if we print out options now, it basically stores it as one big string. And that way I can throw it into the random.choice function very easily, right? So if I do random.choice now on options, it will choose one of the lowercase letters or one of the uppercase letters or one of the numbers. It will choose it, but it won't show you unless I print it. Very common mistake that I make even to this day, as you can see. So O, V, capital K, L, or 1. I don't know, the font, that's an L. A, capital L, V, R, lowercase l again, 5. So we can see that these are all just different ones that pop up. So how do we make a 8-letter password out of this then? Well, we need 8 letters. We can do this same operation 8 times. So we could just simply do something like this. Password is equal to random.choice options plus random.choice options, copy 1, 2, 3, 4, 5, 6, 7, 8, right? And copy paste, bad input on line 11. What did I do? Oh, equals. Where'd that equal sign come from? Go away. Ooh. Okay. Run. I messed up something over there. That's funny. Okay, I think I got them all. Nope. Oh, okay. Yeah, I see what I did wrong. I just made a terrible job of copy pasting. So, yeah, color me embarrassed. So Control C, Control V, still did a terrible job of copy pasting. Right? 1, 2, 3, 4, 5, 6, 7, 8. There we go. And now print password. But as you can see, copying and pasting has difficulties, right? This is an 8-letter password, so it fulfills what we want. But copying and pasting has its difficulties. Also, it's hard to read. It's hard to count how many there are precisely when you're writing it. So instead, let's use a for loop and use something called the accumulator pattern. So our password is currently empty. But for blank in range 8. So just simply repeat this statement 8 times. Password is equal to what we currently have in the password concatenated with a random choice out of our options for the password. Now, let's see. And now I'm going to print out the password each time that we select the letter, so you'll see that how it grows. So selected P, then N, then E, then F, then A, then K, and then Z, right? What we did is that each time we selected a letter, we concatenated it with all the other letters that were already there. Does that make sense to everybody? Did I lose people here or no? Let's see, where's my chat? Okay, so could I explain again? Which part specifically needs to be explained again? Okay, so we have the import random, right? The idea here is that we're generating a random password. So let's see. The reason it's printed like that, right, is because I have the print statement inside the for loop. If the print statement was outside the for loop, then if I run it, it just comes up with a password at the end. But I wanted to show what happened as it progresses so that I could emphasize what happens at basically that each step, what it's doing is it's taking a letter from options and adding it to the password. So password plus, so for instance, the first letter we choose is 4. So we add 4 to empty string and store it in password. And then we print it out. The next letter we choose is 1. So we take 4, which is stored in password, add 1 to it, and so that becomes 4-1, and then we store it in password. Then we do the same for O. We take 4-1, add O to it, store it in password. So that's how that works. Now, what is options? Options is just simply all 3, the letters, caps, and numbers concatenated together so that we can use this handy dandy random.choice, which randomly chooses one of whatever sequence you put in there. And this work, I just did this with strings, but what's wonderful is that this works with lists as well. So we just simply imported random. These were already provided for us. We added all these together. So we concatenated that, we glued them together into one mega string, which is this guy. We printed it out to show it to you. Then we have our password here, and we just simply added a letter each time this loop ran. We ran it 8 times because it did, in the comments, ask for 8 letters. If I wanted to do a 16-character password, it's not too hard. I just switched this to 16, but try not to destroy the the colon or the brackets. So there's a 16-letter password, right? And it's hard to count this and see it's 16. So that's a lot of times why people use a for loop instead of just copying and pasting, because we can have control over this. 8 letters is generally the minimum size for a password these days. So, but if there's a sane policy like Temple has actually for the passwords, we could use something rather long that's easy to type out and easy to remember. God knows the amount of times I've forgotten the password. Why don't we need end after the for loop? We don't need an end because we know that because Python knows when it gets to the end of a for loop and it doesn't see any more indentations, it doesn't need to end. The end is implied by the fact that you've got this. End is actually out of most programming languages right now. We know it ends after 8 runs. Python is meant to be very terse and concise. All right. Does any more questions on this? This will make more sense as you use it. Seriously, I had insert turned on. That was annoying. So now, for your task, what you're going to do is you are going to use the XKCD model of selecting 4 random words and concatenating them together with a password. So you have, instead of letters, caps, and numbers, you have nouns, verbs, and adjectives. Now, these are lists, which means these are sequences, which means they work the exact same way as the strings over here. So I'm going to share the code with you, this guy over here. You should be able to load it up on your page by refreshing it, and then, or going into show history over here. There's a button over here, experiment to see where it is. I'm seeing what the instructor sees, not what you see. And if you need some help seeing how it works, you can always hit the show and code lens, which will run through the code and show you the variables as it goes through them. And the output as it goes through it. So it's a very useful tool. So, whoops. All right. So with that, go ahead and let's work on activity part 2. I'm going to give you some time to work on that, and then we'll come back to this point. Okay? What would be the limit? In what sense? How long? You use 4 words. use 4 words. I'll give you about 5 minutes, and then I'll ask how people are doing. Okay? So with that, I'm going to not distract you, which is something I have a bad habit of doing. Click on participants in the Zoom window if you don't mind. And just to poll, hit yes if you were able to get it done within, if you're done with it now, hit no if you're not done with it. And when I say it, I specifically am referring to the activity 2, not the entire page. All right, so I'll give a bit to work on that. I'll let people work on that for a bit long since people are working on it. If you want to explore further, you can. But I'm going to make sure, but since there is a nice chunk of the class that's saying no, almost a quarter, I'm going to go ahead and give a bit more time. And all right, so let's go ahead and show you how the solution to this one. It's actually fairly straightforward in terms of moving from one question to the other. So what I'm going to do, so make a 4-word password by combining words from the list of nouns, verbs, and adjectives. So we've got all these words already conveniently set up for us. Be ashamed not to use them. So let's go ahead and say words is equal to nouns plus verbs plus adjectives. Okay, now what we've got to do is we want to make our password just like we did earlier. The only difference is that rather than creating, actually, yeah, we're going to just create a empty string like we did earlier. So first off, just to show you, we concatenating, as I mentioned, concatenating strings and lists works the same. Sorry, concatenating lists works the same way as concatenating strings. So this is all of them together. So now we've got now we've got an empty password that we're going to start adding words to. So for blank in range 4, we're just going to do this 4 times because we have 4 words. Word is equal to random.choice words. I'm breaking this up into one line, essentially into 2 lines. So we get a random word. Password is equal to what we currently have with password, what's currently stored in password, plus the random word we just chose. So password is, so we store inside a password what's currently stored in password concatenated with the random word we just chose. Let's go ahead and print out the password now that we're done. And save and run. Okay. Error, random is not defined on line 9. What did I forget to do? And by the way, this was not a deliberate error on my part. This was an actual mistake I just made. Yep, import random. I immediately knew it was wrong, but I mean, I immediately knew it was wrong because I've made that mistake plenty of times. Transfer developmental actual perception. Constitutional data gather intents. Disaster following language funeral. Back resistance headquarters escape. Poll impose rub cruel. Operate date colony persist. So this is doing fairly effectively at doing this. So let's take a look at the next one. So our IT department So our IT department's pretty cool with the passwords, but not every IT department is cool with the passwords. They still want you to have at least one capital letter and one number in your password. So we'll learn about this in a couple chapters, but it's pretty easy to use to replace parts of a string with the replace method. So, for example, pool, replace, it's very easy to become a pun generator. You just have to become a dad, and then it just like instantly, it's like you instantly have to make dad jokes. It's irresistible. So, for example, pool.replace O with E gives us peel. Once you have your, so replace all the O's with E. So when you have your final password, you can replace some of the letters with number substitutions. So, for example, it is common to replace the letter I with the number 1, or the letter E with 3, or 0 with a O with a 0. You can get creative. You can also easily capitalize a word using myword.capitalize. Once you feel confident you understand the code below, you can use the active code window to make your password compliant with the standard procedures to include some special characters. So over here we see word.replace. So we have word pool, word.replace O with E gives us peel, and then word is equal to word.capitalize. So again, as I've mentioned many times, strings are immutable. You cannot change a string. So what word.capitalize does, it's that it does not change, it does not capitalize the word. It creates a new, it's subtle difference. It creates a new word. So it creates a new string that has been capitalized for you. And then we replace the old string with the new one. All right. So, all right. So let's go ahead and you can take some time to do that. If you're on the next part with this guy, if you've already done that part and you wanted to, and you're already on this part, so let's go ahead, let me talk about what this does. Can you just capitalize word.capitalize G, for example? Well, what's G? No. I don't think so.
I have a question.
Yes.
So when we get our password though, we don't know which letters or numbers it's gonna generate.
Right.
So do we have to like check if the letter or number is in the password and then change it up?
Nope. Watch. If I replace all the E's with O, it's saying replace all the E's with O. And he's like, yep, did my job. Replaced all the E's with O's.
But I don't know if there's going to be an E in the password.
Right. No, you don't. But that's not, but you don't need to check it. We're just basically want to replace like our E's with 3s or our O's with 0s or our L's with 1.
Oh, okay. So for this assignment, we don't generate a password. We just kind of...
Well, with this, well, you do. You take this and use what you learned here to basically make it so that your password will include a capital letter and a number.
Oh, okay.
Okay. Now for activity 4,
thank you.
I'll go over this in more depth about this, but it gives you a lot of code. This will make it so that your code does not stop after after running for 60 seconds. Sorry, it makes it so basically, typically it will automatically crash if like your code runs for 30 seconds. This sets to auto crash if it's not done in 60 seconds. So here it's saying, here's somebody's poorly chosen password, ABCD. And what it's asking here is, I want you to basically figure out how many guesses you need to make to find that password, ABCD. So we can look at that. We'll look at that in a bit, but it doesn't take too long. So let's go. So go ahead and work on part 3, which is basically you want to make sure that there's at least one capital letter and one number in your password. So we're using this as a base. All right. So you can go ahead and get started, and I'll give you 10 minutes. And I'll leave this, and I'm going to leave this up in case you need it. Okay. Let's go ahead and now take a look at how to do part 3. I'm going to just simply grab the code from up top, because what we wanted to do is that we wanted to take our password and we wanted to replace, and we wanted to update it for password patterns. So we would say password is equal to password dot capitalize. And now we want to do password. We'll print it out to show the progress we're making. Print password dot, oh yeah, and then password is equal to password dot replace E with the letter 3, because we want numbers in it. So password, we'll just simply copy this from above and we'll just change it as, we'll just change a couple things. So we'll change I's into 1s, O's into 0s. We'll change A's into 4s, and S's into 5s. This will probably mean that we do get some random letters. So, and we're just simply going to put that, and now we can get rid of this stuff and print password. Yeah, now that's a pretty obnoxious, but that works. All right, so let's go ahead and look at this. So let's suppose we do have a 4-character password that composed of only lowercase letters. How many guesses would it take you to guess the password? You can actually write a program to create the 4-character strings and compare it to the known password. If we put this process inside a loop, we can keep track and see how many guesses it will take us to find the matching items. So let's go ahead. It says your code here. Basically, we just simply, and that, so what this does is says, hey, ABCD is equal to, is the password we're trying to guess. We're going to keep track of the number of guesses we have, 0. Can I share the last code? I will share it. So, and then done is equal to false. So this is a Boolean statement. It has true or false values. The true and false values so true and false. We'll learn about about these Boolean values in more detail when we get to, I think, chapter 8. But for right now, just know basically while not done. That makes sense, right? While we're not done with this process, keep doing this. This is what we call an indefinite loop, a while loop. It's like a for loop, but for loops are definite loops. You definitely know that this for loop is going to run 4 times. You use a while loop when it's indefinite. You have no idea how long it's going to run for. So what we do here is we create our password, and if the guess password is equal to my password, count it again after num tries. So we could actually be a bit silly here, and I'm going to be a bit dumb to begin with. I'm going to grab letters from here, and I'm going to grab random. No, we already have random. So I'm just going to grab letters over here. Gonna slap it down right here. And again, this is going to be dumb and not optimal at all. For blank in range 4, I'm going to say random dot choice letters guess password is equal to what we currently have guessed for the password plus a random letter, because we know it's 4 lowercase letters. Okay, and now if password is And now I'm not done yet, but let's go ahead and run this because this is close enough. So if password is the same as my password, again, another Boolean statement, right? This stuff is all stuff we've learned about, except for the or we were immediately introduced stuff. This is okay if you don't understand if guest password is equal to my password. But basically this will say if the guest password is the same as my password, print out that it's found, and then set done to true. And because done is true, while not done is no longer true, so it will stop running. Again, we'll learn more about those. So now we hit save and run, and as many people mentioned, it basically locked up their screen. This is because this is completely random. It is just simply throwing random letters together in the hopes that it works. A page is going down my web browser. What would you like to do? Well, it found it after 0 tries, it says. What did I do wrong? Anyone? I didn't count, right? Guess num over here. What it was doing is that its purpose is guessing, it's keeping track of how many passwords I'm trying. So what I'll do over here is I'll say guess underscore num is equal to guess num plus 1. So I'll just simply increment this guy by 1, which I could shorten up to by plus equals 1. So now we run it and let randomness do its thing. I've got a fairly fast computer, so if this is running completely locally, all right, it found it after 399. It basically found it after 400,000 tries. Okay, save and run again. And again, it's all completely being done at random. It's not methodical at all. Okay, so yeah. So this time it took about it took about 900,000 tries for me to get. And I mean, we could do a more methodical way of doing this with some nested for loops. So let's see. Four-letter passwords are fairly easy to guess, right? It's taking us about, I'd say about 1 million on average to try to find it. Okay, so it can be a lot. Now, if we tried to increase this to make a 5-letter password, it would it would take a lot longer, right? So let's see. Let's do some quick. So this part over here is to do some quick math. So assume that so basically you're trying to figure out how long does it take to guess this password? How long would it take for you to guess a password that's that's made like this in 4 seconds? It took us less than a minute. Or, sorry, a password that's 4 letters long. How long would it take to guess that? And then this is asking how long would it take to guess a password if it's 5 characters, or 6, or 7, or 8, or 9, or 10 characters? How does this change if we allow all 26 letters plus 10 digits? What does set execution limit do? This makes it so that by default, in the browser, to make sure that your computer doesn't get completely locked up, Python will automatically crash after running for 30 seconds and not ending. So what this does is says, I'm going to set this to run for 60,000 milliseconds. And then let it run. Derek asks, will this code do repeats, or does that code not repeat the same 4 steps? It's completely random. So it could guess AAAA, and then it could guess AAAB, and then AAAA again. It could totally just go back and forth. If you want to do something more methodical, you need nested for loops to do it. But let's go ahead and run it one more time and see how long that takes. So it takes a while. Why do we have 2 imports instead of 1 import? Because we are using because we're importing 2 different libraries. One is we're importing both the random library and the system library. So let's go ahead and assume on this computer that it takes about 20 seconds to do 1,000,000 guesses. Okay? Let's say it takes about 20 seconds to do 1,000,000 guesses. So now use that information to calculate how long would it take. I want you to try to calculate how long would it take for you to guess using a brute force attack, which is what this is, a password that has 4 characters and a password with 8 characters. All right, that's your task. Calculate, given that it's going to be that you can do 1,000,000 guesses in 20 seconds. And let's further assume that random is going to be nice and it's only going to check each possible password once. How long will it take it to find a password with 8 characters in it? The answer should be something fairly long. Definitely less than 20 seconds, or definitely longer than 20 seconds. All right. So this part really isn't so much important for this bottom part to try to figure out. All right. So I'll give you some time on that. I'll be around in the chat. Once we're done with this, we'll turn it in, and then I'm ready for demos. All right, so since there's about 11 minutes remaining, I will go ahead and go over it. So we've got to figure out how many, so basically let's go ahead and see. If we've got a 4-letter password, how many possible passwords are there of 4-letter passwords? How many possible different permutations of 4-letter passwords? Yep, 26 to the 4th power, right? So, right, because if we've got a 4-letter password, right? If we've got some kind of password right over here that's 4 letters, 1, 2, 3, 4. Let's put dashes instead. Right, we have 26 possible letters to go here, 26 possible letters to go here, 26 possible letters to go here, 26 possible letters to go here. That is in combination. Basically, we've got so num passwords is equal to 26 to the 4th. Because it's 26 times 26 times 26 times 26. Because there's 26 options for the first one times 26 options for the second one times 26 options for the third one. That's how many there are. Num passwords. So there's about that many. So it should take my computer, if we're doing 1,000,000, it should take my computer about 10 seconds to do that, to be able to find one. Notice that it took my computer more tries than there were. This is because of the randomness process that was involved. Because we guessed multiple combinations twice or 3 times. So let's go ahead. So basically, how long will this take? Basically, if we're trying to do 1,000,000 a second, then let's do num passwords divided by 1,000,000 for every 20 seconds. So that's 1,000,000 every 20 seconds. So basically, if we've got a million, so if we've got a million if we've got a million every 20 seconds, how many is that per second? Right. We would divide by 20 over here. Right, a million per every 20 seconds means that it would be divided by 20 to get the per second basis. So the amount of time it would take is time is equal to, or runtime is equal to number of passwords divided by guesses per second. And then print runtime. So it will run for about 9 seconds. Like I said, it would run for about 10 seconds. So now let's go ahead and up the ante. If we do 5 passwords, so if we do a password that's 5 long.
Pause. Can you unpause it?
Can I unpause it for you? In a bit. I'm working with my
What are those guys?
what are those guys? Those are my students. Those are my students. So let's go ahead and laser. I'm almost done with class. Can you try unpausing it yourself? All right. So if we so making the password 1 character longer makes it 26 times you have 26 times more passwords to go through, which makes the runtime 26 times longer. So that is 237 seconds. Or in other words, divide by 60, that will give us about 4 minutes. Now, if we go up to an 8-letter password chosen at random, it takes about, that's a lot of possible passwords. And so it would take 69,609 possible minutes at that rate. Let's go ahead and, so that's minutes, and there's 60 minutes per an hour, which will be about, no, there is not a way for the code to go through to prevent randomness from being more than once. So it'll take 1,100 hours, which is, well, let's convert that into days. 24 days. We'll take 48 days. So that's if we're just using lowercase letters. But as we know, there aren't just lowercase letters, there are uppercase letters too. If we suddenly made it uppercase letters too, that would go from 26 to 52, which suddenly means that it takes 12,000 days, or divide by 365 days per year, 33 years to guess it. In a properly running algorithm that which would require nested for loops would not, in fact, would not guess the same password multiple times. So we're going off of that. So it takes 33 years for that to run. If we're just using letters, and if we add in numbers, it just gets worse and worse and worse. If we add in numbers, let's go ahead and add in numbers and an underscore. And suddenly it's 157 years to crack an 8-letter a truly randomly generated 8-letter password with not just letters. And if you use 16 like they suggest, yeah, we have to go into scientific notation. These are unlucky. This is unlucky. So this is the chance. So this is if you have to guess all the passwords. On average, how long would it take? It would take about it would take about half the amount of time, because you would have to go through half the passwords before you found it. But half isn't that big in the grand schemes of things. Now, if we were to go back to our original premise, though, 20 characters that are easy to remember, 4 words that are easy to remember. No, a supercomputer can't crack your password. Well, it depends on if your password's really short, it can. Anything that's like 8 characters, no. So let's go back to using 26 letters. But now let's look at using just lowercase letters and using 20 of them. I'm not even going there. Quantum computers, we don't know how to take that. It would take this many years for a computer to guess it, which is hundreds of thousands, millions. I think it's in either hundreds of trillions or hundreds of quadrillions. It's a bit hard to check. Right, let's go with let's go ahead and divide by 100. Let's go ahead and divide by million to see how many millions of years it would take. It would take, was that really the case? Yeah. It would take 1, 2, 3, 4, 5, 6. It would take 6 billion million years. So it would basically do that. If you want to know about quantum computing, Dasgupta's algorithms, which is in 3223, has a really good write-up of it on the way it works and how it affects runtime. So that's the textbook we use for 3223. I don't think we go over chapter 10, which is the quantum computing chapter, but it's there. And so I find Dasgupta's algorithms to be a very good resource. So anyway, 3223 is data structures and algorithms, CIS 3223. So for computer scientists, the sequence is 1051 or 1057. Then you take 1068 with Professor Fiore, 2168 with me or one of the other professors who teaches it. Then finally you take 3223 with Professor Hughes. So something that takes this long is very hard to guess. And even so, just using this passwords are very strong. So that's what I've got for you today. I'm going to go ahead, stop sharing, stop recording.